Right, so in the previous video I talked about some of the various mathematical properties of functional dependencies. There's one more very important formal aspect of functional dependencies, and that's the notion of closures. Now typically we're going to have a set of functional dependencies associated with a schema, and we had a little bit of a look at that when we talked about the movies database. So we had a movies table with title and year and runtime and genre and actors, and we saw that the title and the year determined the runtime and the genre because they were talking about a particular making of particular movies, so the King Kong 1980 version. All right, so a given schema may have a large number of functional dependencies, so let's draw some, and typically we'll write the set of functional dependencies as F, and since it's a set we can put it in braces, and let's imagine that we have a set of attributes A, B, C, D, the usual kind of names, and we've got these functional dependencies. Okay, so what can we learn about these things, or what can we infer about these things? So there's one notion of all of the functional dependencies that you can infer from a given set of functional dependencies. Well, given the fact that AB determines C and C then determines D, one thing we can add to this set, so the set of the closure of the functional dependencies F includes obviously all of these functional dependencies, but we can also add AB determines C, C determines D, therefore AB determines D. And the other thing that we can add is that F determines G and G determines E, therefore F determines E. And that kind of process is known as transitivity of functional dependency. So we talked about being able to break a functional dependency up. So A determines B, C, D can become A determines B, A determines C, A determines D. That's one kind of rewrite rule. This is another important kind of rewrite rule on functional dependencies. Now, any realistic schema is going to have a large number of functional dependencies, and if we try to compute the closure of the set of functional dependencies, it's actually going to end up being extremely large and difficult to deal with. So another kind of closure that we make use of is the idea of closure on a set of attributes. Okay, so we talked about closure on functional dependencies. We can also have a closure on the set of attributes, and we typically denote that. So let's pick a couple of attributes, A and B, and the closure based on them are all of the attributes that can be functionally derived, if you like, from them. So that would give us the set A, B, they can determine C, and C can determine D, and so that would be the closure of AB plus, of AB. Also, we could take the functional dependency F, and the closure based on that would be F, G, and E. Okay, so F determines G, so we increase the set to that size, and G determines E, so we make the set that large. Now, one thing that we can use these kind of closures for is for determining keys. Now, a key is something that allows you to functionally determine all of the other attributes in a schema. Now, in this case, AB is not a key because it doesn't determine all of the other attributes. F similarly is not a key because it doesn't determine all of the other attributes. However, if we take A, B and F, then the closure of A, B and F is going to be all of the attributes. So it'll basically be the union of those two sets. And it doesn't matter what order I write them in. That, okay, so AB allows us to determine these, and F allows us to determine E, F and G. So A, B and F is a key for this relationship under this particular set of functional dependencies. So that idea is going to be useful when we start talking about decomposition.